Okay. Yeah, so let us begin with our session 3 on OpenMP. So in previous session so far what we saw is how we delved deeper into the shared memory architecture, and we saw how the what is the process, what are the threads and how they are arranged in the RAM, and we also saw few details around threads and processes. So we saw what is shared, what is not shared within among threads. And then we move towards what OpenMP is. So basically, it's a shared, directive-based API for shared memory systems, and yeah, it is used as benchmark for writing shared parallel programs for shared memory systems. And yeah, then later we saw something called as how we can define parallelism in OpenMP. So we saw what is master thread, what are child threads or slave threads. We saw what is the serial section, what is the parallel section, what is nested parallel section, and so on. And later towards the end of the session, we saw this, right? We saw OpenMP constructs. So just to recap, so we saw two things here. One is pragma and runtime routine. So pragma are nothing but something which directs the compiler to parallelize the section of code. And we saw this syntax, right? The way to define any pragma is to to write hash pragma MP followed by directive and clause. So directive can be any of this, parallel for or parallel for, so on. And clause can be something that gives more information on this directive. And we also saw this using our hello world example. We saw what was the directive there and what's the clause there. And we saw this runtime routines, which are used to set and retrieve some information about the environment. And we saw this too, right? First two we saw like set num threads and get num threads. So I think we didn't saw third one, but yeah, we'll see this one today. Yeah, so let me share the program with you. Mhm. Yeah, so this was the hello world program that we saw, right? In which we were first doing some check based on the command line argument. So if there is no command line argument, then we were throwing error. Else we were setting the number of number of threads based on the command line arguments, and and yeah, then we were launching parallel section. We were having this parallel section, and in which we were calling hello, and this hello was using this runtime uh, routines, which are get OMP get num threads and get thread nums, and we were printing those. So basically, OMP get num threads will give the number of threads, and get thread num will give the thread ID of each thread. So there is one small modification that I've made in this code. So sorry, I have added the OMP get max thread here, and yeah. So basically, I'm trying to print OMP get max thread here. So is there anyone who knows what will be the expected output here? So what exactly this directive does? Does anyone know? What does it output? You can unmute and say, or you can type in chat also.
It maybe give you the maximum number of threads that are available.
Okay. Any other thoughts? Okay, so sorry. Okay, so what this OMP get max thread does is that it gives number of threads greater than or equal to the number of threads that will be used when you define this OMP hash pragma OMP parallel without specifying any num threads. So in for my system at least, so in our case, what will happen if I launch this parallel section without specifying the num thread? This is like this. So it will launch it with 4 threads, right? Because I have a 4 core system. So what OMP get num threads should return is that it will return the number which is either 4 or greater than 4. So this is what is the formal definition for OMP get max threads. It will return number of threads greater than or equal to the scenario in which you run OMP Pragma OMP parallel without specifying the number of threads. So let us try this program and let us see what's the output. So for now, I'll just comment this out for the sake of simplicity. And let us run this program. Okay, let us clear this out first. And let us run this one first. Okay, let us give any thread number of threads. So you can see here, right, that it is giving 4. So the point here is that when I don't specify, I mean, it should, when I don't specify the number of threads here, it should run with 4 threads. And what OMP get num thread is returning is that it will return either 4 or any number greater than 4. So if your system has 6 core, then it might return any number 6 or greater than 6, any number greater than 6 or even 6. So I hope this is clear. Any questions around this? So this was one point that I forgot to cover in last session. So I thought I should cover this one. Any questions till now? If there are no questions, then we can go ahead. Okay, then let us start with our today's agenda. So in today's session, we'll look into mainly the error checking part, and we'll also look into the scope of the variable. So we'll see what are the different scopes that we can define for our variables in our code, and we'll see multiple examples and we'll work out through multiple scenarios, and yeah, we'll solve many problems today. So yeah, so be interactive and please ask questions so that we can all get some clarity here. So yeah, let us start. So error checking is nothing but placing appropriate checks within your course so that your program doesn't end abruptly. And this is even true for our OpenMP program that we write. So in general, it's a good programming practice to add such checks, and it helps to prevent getting incorrect values, incorrect results in your code. So let us go back to our Hello World program. So the simplest error check that we have done here is specifying the, checking the command line arguments, and based on that, taking some steps, right? If there is no command line argument, then we specify here that please enter the second argument so that we can launch the appropriate number of threads for our parallel section. So this is one form of error checking here. What can be the another form of error checking? Anything that you can think about? What can be any other form of error checking here for this code? So what checks can I place here so that
do while to
yeah.
check whether the number of codes is whether the number of codes user has given is less than 0 or that cases.
Yeah, that can be one of the scenario. Any other? Any other thoughts?
Or modifying this arg to just return 1 and 0.
Sorry, can you repeat what? Splitting what?
Modifying this command line argument check to return 1 or 0 at the program returns 0, so that If the program goes wrong, you return one immediately right away.
Yeah, that can be a good check. So what I had in my mind is that, like, what we can do is uh, based on some, we can also add some check based on thread count maybe. So let us say that if user has given some abrupt number of threads, let's say 10,000 or 1 lakh threads, then sorry, we can place a check here saying, uh, we can place some check on thread count such that if number of threads are less than let's say 1,000, then only run the parallel section, right? Otherwise, no need to run the parallel section. So what we can do here is that we can place this entire thing inside a for loop, and sorry, if condition, not for loop, if condition, and yeah, we can write an else section such that yeah, in this we can write any error message like please add, please specify. Right, so this can be one of the error checks. Apart from this, what can be some another error checks? So this can be done, right? If well, command line arguments won't be less than 0, because each time when we launch, we launch our program, there is at least one command line argument that is given, which is the main sorry, the name of the program. But yeah, if it's, we can do this, like if it is if it is greater than 2, maybe then we can print something that please specify only just 2 arguments. So uh, only the name of the program. Apart from that, you should specify only one more argument. So we can specify that. But yeah, for now we'll keep this as it is to keep things simple. So this is one of the check. Apart from that, if anyone has any suggestions, then you can tell. Otherwise, we can move ahead here. So there are a few more things that I want to share here for error checking. So this is one, right, that we want to prevent the incorrect values, and for that we can place some check. Apart from that, there are a few other things that you can do as part of error checking, that you can add some flags. You can add some conditions within your OpenMP code such that sorry, such that your code compiles even if you provide the FOpenMP flag or not. So what I'm trying to say is that let us say that you have this current code, right? This one, right? If you compile this code, this hello world code, will it compile? First of all, if you compile it without using FOpenMP flag, will it compile? Any idea? Will it compile if you don't specify any flag like FOpenMP? Hello, am I audible? Are people typing in chat, or I can't hear anything? That's why I'm asking. Okay, so the point that I was trying to specify here is that when you try to compile this code, okay, let me share this again. When you try to compile this program without using FOpenMP flag here, it will it should give error, right? Because it doesn't know what sorry, what this get num thread OMP get thread num etc is. So it won't compile. it will throw this error. So idea is that we want to write the code in such a way that it will compile even if it is even if we uh, even if we have this runtime routines, right? And it should compile even if we don't give the fopenmp flag. So ideal scenario is that it should run in this scenario also. So when we try to compile in this way, it should compile even if we have this runtime routines and all those this OpenMP pragmas and so on. So let us try to modify this code so that sorry, so that it can be compiled in using without using fopenmp flag. Just give me a minute. I'll have some water. Okay, so let us see, look into that one. I mean, the program where we can, without using fopenmp flag, we can compile the program. So it should compile in both the case. If we provide fopenmp flag, then it should run things in parallel. And if we don't provide fopenmp flag, it should run the serial version of code. So that is what is the expectation. So let us look into that part of code. So let us look into this. So the serial port, I mean, this portion of the program is similar. So we are not adding any checks here. So this is the version 2 of the program. We are not adding any checks here. But if you can see in this portion, there are some changes. So first of all, I have placed this hash include openmp.h in something called as
Excuse me, sir.
ifdef.
Sir, the code is not visible. Could you share the code, please?
Oh,
Your
sorry.
terminal is visible. Yeah.
Yeah, sorry. I was just wait. Yeah. Yeah, is it visible now? Can you?
Yes, sir, it is. Thank you.
Yeah, so what I was mentioning is that now we are looking into the code which will compile which will compile in this scenario even if we don't provide the fopenmp flag. So if we provide the fopenmp flag, it will run in parallel, and if we don't provide the fopenmp flag, in that case it will run as a serial program. So we are now looking into the hello world v2. I mean, the version 2 of the hello world program, and this program has some additional error checks. So let us look into that. So what I have done here is that I have placed the hash include openmp.h in something called this ifdef. And sorry, we have this environment variable underscore openmp. So this environment variable will tell us whether the openmp is enabled or not. So if openmp is enabled, then this underscore openmp will have the true value, else it will have false. So by placing this hash include openmp.h in ifdef check, what we are essentially doing, here is that based on whether OpenMP is enabled or not, will enable this line. And similarly for other checks also. So for example, in this hello function, there are a few things that are specific to OpenMP, right? So one is the OpenMP get num threads and OpenMP get thread num, right? So these are runtime routines and these are specific to OpenMP. So if we don't specify that fopenmp flag, it won't recognize these things, right? So that is the thing. So we need to place this also in this ifdef. And sorry, if this OpenMP is enabled we'll check this using underscore OpenMP. If it is enabled, then we'll call this runtime routines. Otherwise, what we'll do is we'll specify some default values inside else. And yeah, we'll end if that yeah, here. And we don't need to place this hash pragma openmp parallel in ifdef, because by default, if openmp is not enabled, then this line will be ignored by openmp. I mean, serial code, it will be ignored. So yeah, any questions? So what we are essentially doing is that we are using this environment variable called as underscore openmp to check whether OpenMP is enabled or not, and based on that, we are placing few lines of codes in such a way that those will be triggered only when OpenMP is enabled. I hope this was clear, or if there are any questions, then please feel free to ask them. Okay, so now let us, if there are no questions, then let us try to compile this program and run it. Okay, so now let us compile this. So let us try to first compile it using fopenmp flag. It should compile, right? Even using fopenmp, it will compile. And without fopenmp, it should also compile because we have placed those statements inside if check. So if we are not using OpenMP, then even then it should get compiled. So that is what is the expectation here. So it is getting compiled, right? So even if we don't specify the fopenmp, that is, if we try to run this program in serial, then it should not give error. I mean, it should compile and it should also run. So let us try running this. Let us give some random thread number. So now the thread number will not matter, right? Because the number of threads will only matter if we are trying to run it in parallel. But when we are not using fopenmp flag, it will anyways run in serial, and specifying the number of threads doesn't matter. So yeah, it says that thread num0 in the team of size 1 because we are running it in serial. And let us try to also run once in parallel using fopenmp flag. And let us try running with same 5 number of threads. So yeah, it is giving some output, right? So I hope you got the point here that we should write the code in such a way that it should also be, I mean, even if we don't specify the flag, fopenmp flag, then also it should be able to run in serial. And the same code we should be able to reuse to run, I mean, should be able to reuse to pass the fopenmp flag and get it run in parallel. So I hope you got this point. Any questions so far? Okay, so this is what I was trying to explain. So your code should be such that it should be able to run without the fopenmp flag, and this also lets let you as a programmer to prevent uh, keeping track of two separate version of code for serial and parallel versions, right? So you can use same code as a serial version as well as the parallel version. So you know don't need to maintain a separate copy for the serial version and another copy for a parallel version of the code. Same code can work as the serial code as well as the parallel code. So in this way, you can write a more robust code. So it's important to add some at least basic error checks in your code. So yeah, as we saw, like we are adding preprocessor directives. So that's this hash if def was a preprocessor directive, and that's this underscore OpenMP that we saw, right, was an environment variable. So we are using preprocessor directive and environment variable to do some error checking. Any questions? Else we'll move on. Okay, if there are no questions, then let us move ahead. Let us go to the scoping part. So yeah, so scope of the variable is nothing but the region inside your code where the variable can be used and modified. So yeah, so that is basically what is the scope of the variable. So there are basically two types of variables when we talk about scoping and when it comes to parallel programming. So these are the two main types. One is the private variable and another is the shared or public variable. So let us go back to our board and see what exactly are things. Let us try to understand this in detail. Okay, so let me pull out my. Let me pull out my. Yeah, so there are two types of variables when it comes to uh, our scenario. So one is private variable and one other is public, or let me put it, shared variables. So private variables are the one which we can they are local to the function, or yeah, they are local to the function, so they can be accessed within the same function. Right? And the shared variables are the one, or let me put it in this way, since we are using parallel programming here. So same function or thread. So they are basically local to the thread. So let us say that you have variable var1, then and let's say you have three threads, t1, t2, and t3. Then each thread here will have its own copy of variable one. Uh, so this variable one will have one copy for t1, t2, and t3, and so on, based on the number of threads. And let's say t1 it modifies the variable one, then its value won't be visible to, that modification will not be visible to t2. So that is what is the private. So each thread has own copy of its variable. And yeah, and the interesting point here to note is that the private variables are declared on the either they are stored either in the registers or the stack of the thread. So if you remember this, right, I explained in previous to previous session that we have this okay, let me switch. We have this structure, right? So this is RAM, and inside that we have this process P1, and threads will be there inside this process. So each thread will have its own set of, it will have its stack, it will have its own set of registers. So the private variable will be stored inside either this registers or the stack of each thread. And since this stack or registers are private, they are each thread have its own copy of registers and stack. So variable declared within this stack or stored within the stack or register will be private to that thread. And when T1 modifies the copy of that variable here, which is, let's say, in register, the thread T2 won't be able to see what is changed, right? So that is what is the uh, uh, private variable. So I hope this is clear. Any doubt still now? Okay, then let us look into the shared variables. So shared variables are nothing but they are the common variables across all the threads. So common across all the threads. And yeah, so what will happen here is that, let's say you have a variable p1 and you have threads t1, t2, and t3. So let us say that thread T1 makes changes to variable 1, then that change will be visible to all the threads, T2 as well as T3. So they'll be able to, sorry, they'll be able to see the change that is made to this variable V1. So I hope this is clear. So now coming back to our example here. So what will happen in general is that the shared variable will be declared within either this process P1 will have its own heap and stack and so on, right? It will have its own heap, stack, some data, something. So they'll be either stored in heap, stack, or data section based on the type of declaration that you are making. So we'll see all these things with the help of example. But yeah, so what is crucial to note here is that they are declared somewhere here, and each thread, when trying to refer when they are trying to refer this variable v1, they'll be referring this copy. And since there is only one copy here, which is with process here in this case, any thread trying to update this variable v1, its value will be visible to, that change will be visible to all other threads. So I hope this was clear. Okay, I think there's some. Okay, any questions up till now? Or everything was clear, or any questions?
It's clear.
Okay, if everything is clear and there are no further questions, then okay, let us switch back to the slides. Yeah, so I hope that this explanation was clear to you. So what are private variables and what are shared variables? So in simple words, private variable is something that is private to each thread. So that variable will be each thread will have its own local copy, and shared variable is something which has visibility across all the threads. So one thread trying to update that variable will that copy, not copy, but whatever one thread is trying to do on that particular variable will be visible to other thread. So yeah, let us move ahead. So there is something called as local and global variables also. So let us quickly cover this also. What are local and global variables? So local variables are nothing but the private variables. So we will use this terms interchangeably. That is private variables and local variables. And and the next thing is global variables. So by definition, global variables are the ones that are declared outside any function. So okay, let me go back to my code screen. So let us say that you try declaring anything outside any function, right? So we have this main function, this hello function. Let us say that you try declaring anything here, right? In let's say flag. Then this is a global variable. So the interesting part to note here is that the global variables are also shared variables. So this is the point that I was trying to make here. Let us go back to this slide. So local variables are like our private variables, and the global variables are nothing but our shared variables. So I hope up till this point everything was clear. If there are any questions, then please ask right now. And else, if there are no questions, then we'll move to the code. So we'll understand scoping in a bit more detail with the help of examples.
I have a doubt.
Yeah.
The access to the global variables are synchronized by default?
No, by default it's not, but we'll see how to synchronize that, but not in the today's session, maybe in upcoming sessions.
Okay.
I think we'll cover one example today itself. I think let us see. Let us see what I have. Yeah, maybe we'll look into it today only. Okay, any other questions apart from that? So this is important. So we need to understand how each thread is interacting with these variables, whether it's a private or shared variable, so that we can understand what can be the desired results, right? So that is why this is important. Shared and private variables. Okay, if there are no questions, then let us move to the code, which is our Hello World v3, that is version 3 of our Hello program. Okay, let us move to this one now. Yeah, I think I'm on v3 only. Yeah, so in this program, what I've done is like everything is similar to v2. We have this error check in place. We have our parallel hash pragma OMP parallel, and we are calling the hello program here. But the only change is that I'm passing two variables here, or rather, let me say that one pointer and a one variable. So we are passing sum and n. So sum is nothing but a pointer to the integer variable, which is initialized to 0, and n is nothing but a simple integer variable initialized to 0. So we are passing that sum and n. And at the end, we are printing the value which is there in sum and printing the n. And what we are doing inside the hello, let us look into that also. In hello, we are, the hello function is very similar, but to the previous v2 version of the code. So we have this team size and TID, which we are setting using get num threads and get thread num. But the only change that we are trying to make here is that we are trying to update the sum and n. So for each like sum and n, we are trying to add the TID, which is the ID of that thread. And yeah, the array checking code is similar. If you can see, we have if, def, else, and else if. And for now, we are commenting this line just for the sake of simplicity. And yeah, this is the code. Now, tell me whether, sorry, the sum is a shared variable or a private variable. As well as same thing goes for n, whether it's a shared variable or a private variable. Either unmute yourself or type in the chat. Either way is fine.
So they are shared variables.
Both, right? Sum and n, both are shared. Is it what you're trying to say?
Private variable, I think.
Okay, any other comments? Okay, let me quickly check what if there is anyone who is typing in the chat. Let me check that also.
Sum is shared and is
So the
private.
yes, as the pointer is shared, but the n will be passed as I think a copy.
Okay.
Both are
Yeah, I
private.
think
Both are private.
okay. Few people are saying that both are private. Few people are saying that one is shared, one is private. Any other suggestions? Just trying to gather all the responses that you have, and then we can discuss so that I can understand your point of views.
So both the variables themselves are shared, like but the sum pointer is passed in the function as a pointer, but n is not. So while we are accessing that in the hello, the n, like there are no possible modifications to n. So I think both variables are shared itself, but sum is the only one being accessed.
Okay, I think I can get your point. So, okay, let us not look at this part. Let us look at this part, this hello function, right? This inside this hello function, right? This function will be executed by each thread, right? Based on the number of threads we are passing. inside this function, what is sum? I mean, is sum a shared variable or a private variable? And similarly, what is that? Like, can you throw some light on that? I mean, just your thoughts. I want to see what you think after our discussion.
So in the scope of the function, since we have a integer pointer of sum, so that can potentially be a shared variable. So because the pointer is being passed in this case, it's a shared variable. But the n parameter that's being passed in, it is passed as a copy of the original value. So that is only limited to the scope of this function. So therefore, it's a private variable.
Yeah. So let us look into this. So I think you are getting it correctly here. So if you look from this point of view, here sum and n are declared inside a main function, right? So this can be considered as shared, but we are not concerned about this. I mean, whether this is shared or private. What we are concerned about is what each thread will get. I mean, whether each thread will be able to access. I mean, whether for each thread it's a private variable or a shared variable. So that is what we are concerned about. So here we are passing sum as a pointer, right? So what exactly is happening here is that, let me go back to the board. So let me pull this out. Yeah, so what is happening here is that this sum is declared as a pointer, right? So it will be somewhere within the heap of the process. So whenever we declared some, whenever we declare some variable dynamically, it mostly resides inside the heap of the process. So it's there inside the heap of the process, and each thread. So, and also we are passing the address. Let us say that this was sum, and we are passing, let's say its address was some 1000. So what we are passing to each thread is its address, and each thread will dereference its address to uh, access the value that is inside the sum variable. So each thread will access the same copy. That is what I'm trying to explain here. And each thread will access the same copy, which is this sum. So it's a shared variable. I hope this is clear. And in case of n, what is happening is that n, okay, let me move back. N is being passed as a, it's passed by value. So the value of this variable n will be copied inside the integer n. So this integer n is a local variable for each thread. When we declared something like this intent inside some function, it becomes local variable to that function. So in this case, it's a local copy for each thread, and each thread will have its own copy of n. So essentially what will happen here is that, okay, let me go back. So this n will be declared somewhere inside stack, or maybe based on the availability of registers, it might be also inside the registers also. So n will be here, and each thread will have its own copy of n. And whatever value is being updated is private to that thread. So let's say T1 updates, it adds its TID in this case, right? It adds 0 or 1, whatever value here. It is adding it to its own local copy. And yeah, it won't be visible to other threads. So I hope that this point is clear. So n is private, sum is shared. Any confusion or any questions? Like anyone who didn't understood
Yeah,
anything
I
here?
have a question.
Yeah, please go
I
ahead.
have a question. So does it mean that if we want to make a variable as a shared variable, we need to pass it to the thread by pointer, by the address?
Yeah, so yeah, that is correct actually, because if you want to make something available to all the threads, then we need to pass it as a pointer. So it should be declared uh, as part of a process, and you should pass the pointer to the variable, and that pointer will be pointing to the common location, and each thread will access the same copy. So that is what is the idea, and it will be shared across all the threads. I hope
Okay.
that was clear. Any questions? Okay, okay, let us move back then. Yeah, let us go back to our code. Okay, now let us say that I do this thing. Let us say that I add this, right? A global variable. Then, sorry, whether it will be a shared or it will be a private. So each thread will update its own copy, or it will be some common copy which all threads will try to update. What do you think now?
So it's a common copy that all threads will try to update.
Yeah. Any other thoughts? Whether it will be a common copy or a shared, or a private copy for each thread?
It will be a common copy only.
Yeah. Any other thoughts? Anyone who thinks that it will be a private copy? Okay, if no one is thinking that, then we are in the correct track. So what will happen is that when you declare a variable as a global variable, then it will be stored somewhere inside the data section of the process. And again, the same copy will be shared for all the threads. So each thread will access the same copy, this copy of the variable. And hence it's a shared variable, right? Every thread is accessing the same copy, so it's a shared variable. I hope this is clear. Any questions on this? Okay, then if there are no questions, then let us. Yeah, so yeah, that was about the global variable. Now, sorry, let me comment this thing for now. Okay, now let us say that I pass this, I declare this sum as integer, and I pass it as sum itself, right? And yeah, obviously I'll remove this dereferencing. So what kind of variable it is now? It should be a private variable, right? Anyone who disagree with that? So after I make this sum as an integer variable instead of a pointer pointing to some memory location, and when I pass it as a sum, it should be a private variable for each thread here. Obviously, I'll remove this thing because it's a pass by value, right? And each thread will have its own copy of sum now. So it will be a thread private variable. So each thread will have its own copy. Now, instead of this, let us say that I do this thing. Now, what will be, what is sum? Is it a shared variable or a private variable?
So it's a shared variable.
Any other thoughts? Whether it will be a shared variable or a private variable?
Shared
So in the
variable only.
function, sir, in the function, are we taking it as a pointer now or as a reference?
It's still as a pointer only, but
Yeah, then it should be a
yeah.
shared variable.
Okay, any other thoughts? Whether it will be a shared or a private variable? So I hope you are getting this, right? What we are doing here. I hope you know like what is this syntax. So essentially what we are doing is we are declaring it as an integer, but what we are doing here is that we are passing the address of that variable. So essentially what we are doing is that we are passing address, and that address is being copied inside some variable, I mean some pointer to the integer variable, which is private to the thread. But yeah, in general, that variable sum is now shared because there is only one single copy for each, I mean, which is there inside some stack or somewhere, and it is being shared across all the threads. So each thread will try to reference, when it will dereference this pointer here and sum, it will try to point to the same copy which is there in the process. So I hope this is clear. If there are any questions here, then please feel free to ask.
So if
Any questions so far?
hello, am I audible,
Yeah.
sir?
Yeah.
The question is, if they have their own copies in the respective processes, it means they all are stored in the RAM only.
So yeah, you are correct. They are stored in RAM. But what is your question then?
So my question is like, when you are defining a pointer, so you are giving the location of some variable to that pointer, right? Memory location. If they have their own copy, so I'm not, this thing is not clear, that does they have like different locations, or just they are accessing that location where that variable is stored?
Yeah, I got your question. Let me share my whiteboard. So let us make this point a bit more clear. So currently the scenario is this. We have a RAM in which we have process P0, which is our program that we are currently running, which is Hello World v3, right? Let us say that we have three threads, T1, T2, T3. Now, what is happening is when I pass it as AND sum and integer sum equals 0. So this sum will be declared somewhere inside P0 as part of, let us say, stack, because it's declared as variable, right? So in general, variables are stored inside stack. So let us assume that it is stored in stack of the process P0. So we have the sum variable here. Let us say that its address is some 1000 and it has some value 0, right, for now. So when we say that we are passing this as a reference, or we are passing the address of the sum, and when we look into the syntax for our function call, right, we have hello int star and sum, right? What is essentially happening is that each variable, I mean each thread here, will have some pointer to the integer, right, which is, let us say, sum in this case, right? Its name is also sum here. They have own copy of integer pointer. They don't have the own copy of some variable. They have own copy of integer pointer sum, and each have I mean each copy will have the address, which is 1000. And when we try to dereference, so when, let's say, thread T3 tries to dereference this sum, which is using star sum, what it is doing is it is trying to dereference this address. So what it is essentially trying to do is it is trying to look the value that is present inside this 1000. And what it will receive is 0 when it will try to do this. And this is true for each thread. So whether T2 does it or T1 does it, it will look, I mean, it will get the same value, which is 0. And let us say that this 0 is now updated to 1. Then also this T1, T2, T3, each of them will now get the value as 1 rather than 0. I hope this is clear. So these are pointers. I mean, they store the addresses. And this is the actual variable. So let me move back to the code. So these are the pointers. Like each thread will have its own pointers. And these actual sum variable is here. I hope this point was clear. If there is still any confusion, then please feel free to ask.
Oh, it's clear, sir. Thank you.
Yeah, so okay. Yeah, so this is clear, right? And some, and apart from that, yeah, now let us look into the output part, right? So we went through the code, right? The entire functioning of the code, we know that, like, how it is modified now. So let us try to measure the output. So let us say that I first of all pass it, let us say that I pass it using a variable only. Then what will be the output for sum and n? Let me remove this also for now. What will be the output for this scenario? If I pass this sum and n as a private variable, then what will be the final output that will be printed as part of our cout?
So the same value that's assigned in the main function 0, 0.
Any other thoughts? Any one thing that it will be other than 0? Obviously, we'll now not dereference it because it's just a sum. Okay, let us try running this and let us verify. So essentially it would be 0, 0 only because we are passing it as a value, I mean, as a value, and it's a thread private variable here. So whatever thread does here is not essential. I mean, here all the threads will be parked, right? When parallel section ends, all the threads will be parked, and uh, the value that we'll see here is what we have defined here. That's it, right? Because that's a private variable. And when threads are destroyed, when when threads are destroyed while end of the parallel region, their local variables or private variables are also destroyed. So essentially sum and n will be 0 and 0. So let us verify this quickly by running this program. Right, 0 and 0. Now let us go back and see the another example. Now let us say that I pass either way, right? Using either this way or another way. So in both the cases, when I pass it using end sum, or I declare it as a uh, declare it dynamically and capture that address in that sum, integer pointer sum. Either ways, we are passing it by reference, and in that case, let us see what will be the output. So what do you think will be the output when I pass it as a reference? So in this case, I'm passing it as a reference here. Then what will be the output? Any thoughts? And also let us place this thing also. Let us add test var. So what will be the output? I'm adding test var also. So test var, if you remember, is the global variable. And I'm updating, I'm just incrementing, each thread is incrementing that. And at the end, trying to print this also apart from sum. So now what will be the output? Any suggestions?
So that sum will give you the address value.
No, essentially we are dereferencing it here. So
Then the no value. What I want to say is that sum will give you the value inside that address value. That's what I.
yeah, but what will be that value? So I essentially want the output, like what output will you see on the screen? That is what I'm trying to get here.
So are we passing n as a pointer as well, because you modified the function to modify the value of n as a pointer?
No. N is still as a pass by value only. If you see
Then,
here,
sir, the
n is
line
passed.
after that pointer sum should be normal
Oh,
and not
sorry.
the reference.
Yeah. Sorry, that was my mistake. I'm sorry. So
Yeah,
n is passed
so
as a variable. Yeah,
so then
value.
that this is the case from the first example, right? Where sum is a shared variable, n is a locally scoped variable, so that's a private variable, and test variable is again because it's in a global scope, it's a shared variable.
Yeah, but what will be the result? Yeah, you are correct that sum is shared, n is private, and sorry, this thing is also test var is also shared. Yeah, I hope this is clear, but any thoughts on what will be the output for this program?
Sir,
So when I
n
try,
n will be 0 in the output. Test where will be the number that we are giving, like total number of like second argument, whatever we are giving, it should add up to that test where, because
yeah,
it
what
is
is that
adding
number?
every time we.
What is that number? Can you
Like
quantify
5
that
we
number?
had, like 5 we gave, right? It is our input argument. Like if we give 5, it will be 5.
Yeah, so
And
basically it's the
some
number of
will
threads,
be,
right?
yeah, and number of threads. And some will be the like sum up to 5, like 1 plus 2 plus 3 plus 5. That will be, I think, 15.
Yeah, so essentially what you are trying to suggest is that sum will be the sum of all the thread IDs.
Yes.
Test var will be the number of threads that we have.
Yes.
And n will be 0.
0. Yes.
Anyone disagreeing with this point?
Yes, sir. So, sir,
Yeah.
n would be 0. Definitely, test variable would be the number of threads that we are running. So, for default case, I think that would be 4. But the sum variable, I think, should encounter a race condition where all the threads are trying to access the same memory at the same time. So, that could lead to some inconsistencies in the result.
Yeah, that is a good point. Yeah, we'll see that. Actually, you are correct here. That there might be some race conditions. So we are trying to update a shared variable. Multiple threads are trying to update a shared variable, and there might be some data race. So does anyone think that there will be a data race with test var also? Anyone would like to go with that?
I think so. There will be a race condition and test variable also.
Yeah. Yeah, so this brings us to a very, very important point. Let me share back the whiteboard again. So if you see here, right, this test var as well as this sum, where they are residing somewhere here, right, as part of this. And there is this shared, there is this copy which is shared among all the 3 threads, right? So what will essentially happen is that each thread is updating the same copy. The same not copy, but same variable they are trying to update, which is residing somewhere here in stack or heap, somewhere in data section somewhere. And when each thread tries to update the shared variable here, what will happen is that we will end up with the data race. We'll look this thing in a great detail in the next session. Don't worry about it if you don't understand it now. But yeah, so essentially any shared variable. So let's say you have some shared variable, right? So in this case, there are 2 shared variables. One is test var and another is sum. When you try to update a shared variable inside, when you try to update a shared variable using multiple threads, that is what is happening here, right? We are trying to update this test var and sum using multiple threads. There is possibility of a data race. And yeah, this is a crucial observation. Anyone who have any question around it? We'll see the formal definition for data race, but for now, just think that since multiple threads are trying to update the same variable, there can be some potential issues that can happen. We'll just look into the definition very soon, maybe in today's session itself, but yeah. Any questions?
I have a question.
Yeah.
The same thing we do it with without a OpenMP also, right? In a normal C program, we can create a global variable, shared variable, create threads, and we
Yes.
can make the threads to access the shared variable, and we can synchronize by putting a critical section. Other than we are using the constructs of OpenMPI. What else the
Yeah.
advantage of OpenMPI?
Yeah. So the thing is that it is similar to, let's say, if you are using some parallel threading library in C, like T threads or something like that, then it will give the similar functionality. The only advantage with OpenMP is that it is API based, directive based language, right? So you don't need to write a lot of code for parallelizing your code. So you can, as we saw, right, that you can just simply use pragmas to parallelize your code. But let's say if you are using some library in C, then you have to write a lot of code for creating thread and then running the threads and so on. That is the one of the advantage of OpenMP. So similar thing, you can do it using other libraries as well. So I'm not saying that you can't do. It's just that OpenMP is slightly more convenient, as well as it is used as the benchmark or the standard for all parallel shared memory parallel architectures for parallelizing
So
codes.
OpenMP is essentially an API.
Yeah, so it's a directive based API. So yeah, I hope you understand what I'm trying to say here. Directive based API. Any questions? Or did I made it unclear or something like that? Okay, if things are clear, then let us move ahead. Yeah, let us go back to this code. So as you people pointed out that there might be a race condition here. So let us try and see if okay, so let us first of all define what is the behavior from our point of view. So let us say that I try running this program using 5 threads, then essentially what should I get, right? For some, I should get 0 plus 1 plus 2 plus 3 plus 4, which is 10, I think. N should be 0 and test var should be 5, right? Because we are running it with 5 threads. So essentially that is the behavior that we want. So let us try to verify, let us try running this code, right? Let me share. Okay, so it compiled. Now let us run it with 5 threads, right? So it is giving 10, 0 and 5 as expected, but this
Yes.
might not be, sorry.
No,
Someone
sir,
was
I was
trying
just saying
to,
yes. No, I was just confirming the output.
okay. Yeah, so what I was telling is that this might not be the case always. So let us try to run it multiple times and see what, I mean, whether we are able to get the data race or not. So let us try looking into that also. Let us modify the code a bit. Let us add the for loop, which I have already added here. For right. So now we are running it for 20 times, 25 times, let's say. So we are running the same code, same function 25 times. Let us see if we can get some data race now. Let us run with more number of threads so that there might be some, okay, no, let us keep the same number of threads so that we can, output doesn't change, right? If we run it with same number of threads. So, okay. So you can, okay, I think test var is getting somehow, its value is getting cumulated, right? I mean, it is adding up because it's a global variable and each time we run it, it should, okay, maybe I'm not sharing the correct screen, I think. Let me. Okay, so I hope you can see the screen now. Yeah, so what I was trying to do is that I tried running this v3 version of program multiple, I mean not program, but the hello function multiple number of times. So essentially 25 times with same 5 threads. And what I'm trying to see is that if I can get some sign for data array. So essentially sum should add up to 10, but looks like there is no value other than 10 that I can find here. So let us go back. Okay, let us comment this for now. We are not, let's say, interested in test where we are just interested in getting the output which is other than 10 for sum, right? So let us do this. Let us go back. Let us try running it few more times. So you can see it now, right? So here it is 9. Sorry. So essentially, if you run this program, the expected behavior is that it should sum the values up to, I mean, it should give 10 as the value for the sum, right? Because we are adding all the thread IDs from 0 to 4, because number of threads we are passing is 5. Now, this is wrong, right? This value 9 is wrong. It should be 10. And this is the example of the data arrays here. So I hope you're getting this, what exactly I'm trying to explain here. And yeah, so how to mitigate this? So let us look into that part also. But yeah, let us first go back and define what is data arrays formally and what is critical section. So yeah, data arrays is nothing but multiple processes or threads trying to access the shared resource. And the shared resource in our case is, sorry, nothing but some variable that we saw, right? It's a shared variable and multiple threads are trying to access that some variable. And that is the classic example of data arrays. And this leads to unpredicted behavior, and unpredicted behavior in this case was that value of sum can take any, I mean, can take any value in this case other than 10. And that is what we want to avoid. And that is data array. So we can avoid this by using something called as critical section. So any shared variable like sum or any shared resource uh, should be placed in a segment of code where each process accesses it mutually exclusive. So only one process at a time can access that. So such segment of code is known as critical section. So if I go back here to our code and if I place this entire thing inside hash pragma OMP critical. So what essentially this does is, so ideally we only want this thing to be in critical section, right? Sum and test were. So what essentially this does is that it will, each thread will have now mutually exclusive access to sum and test were. So even though they are using the shared copy, they'll update the copy one at a time. And yeah, that will, sorry, that will not cause the data errors. So any questions till now? So this hash pragma OMP critical is the directive for adding the critical section. Any questions?
So what critical will do? Will it lock the variable for that thread? Is it like that?
No, what it will do is that the structured block of code. So if you remember, this is a structured block of code,
Yes, yes.
this entire thing. It will ensure that only one thread enters, and after that particular thread exits this structured block of code, only then other thread will be able to enter. So only one thread at a time can be inside this structured block of code.
But sir, the function is working like it is like function is being called inside the thread, right? Because thread is started from some other from our previous function. We have from within the thread this function is called. Now within this again we are putting this directive. So it is like it is called from thread, or thread is being uh, attributed to this function.
Okay, so if I understood your question correctly, then yeah, this entire thing is working in parallel, right? Because we are calling, I mean, this hash pragma OMP parallel. So this entire thing is working in parallel.
Yes.
So is this entire code, right? But what I'm trying to say here is that when I place this couple of lines inside this hash pragma OMP critical, what OpenMP tries to ensure, I mean, will ensure is that uh, these whatever is inside this curly braces will only be updated by one thread at a time. That is what I'm trying to say. Was that your, I mean, did I answer your question, or you are trying to
Yes, I
ask
think
something?
it is like even if separate threads are calling this function at different times or at same time, OpenMP will make sure that if the same line is called by two different threads, then it will allow only one thread at a time and other will be paused or something like a lock.
Yeah, maybe. I mean, the internal implementation, OpenMP doesn't, I mean, we don't know the internal
Okay.
implementation, how
Yeah.
OpenMP does, but yeah, you can think of it in that way, that there is some lock, but yeah, it's at a block level. So this entire block is critical section here.
Yeah.
Just at the end of the execution of a critical section, do the child threads wait for others to finish for synchronization, or do they continue with the execution?
No, I don't think that the child threads would wait here. So maybe what will happen is that, let us say that thread 1 was here, somewhere here, right? Thread 2 might be inside the critical section. Thread 3 might have finished the critical section, right? So it was here. Now thread 1 has to wait, right? Because some another thread is inside the critical section. But that doesn't mean that all the threads have to wait for thread 2 to finish. Thread 3 can proceed, right? Because thread 3 is already done with its critical section. It can execute the statements that are after it. It will not wait for thread 2 to finish it. Only thread 1 will wait because it wants to enter the critical section, and some other thread is already inside the critical section.
Okay, so
So yeah, so simple answer is no, because there might be a different scenario also where threads might not want to wait. I mean, need to wait actually, not want.
I have a doubt here.
Yeah, go ahead.
This pragma critical construct made the critical section and synchronize. It has given the synchronization. Is there any way that we can control the order of access? I mean, the thread ID 1 can go first and thread ID 2 can go second, like that. Is there any construct? Pragma construct.
I think that actually I am not aware of any such construct, if there is any, but maybe you can control it using maybe single section or something like that. So we'll come to it what the single section is. But let us say that if you want a specific thread to enter a particular block of code, then there are some construct for that. But frankly speaking, I don't know any construct with using which you can based on thread ID you can restrict a particular thread to enter in a particular order. I'm really not aware about such function.
What is that you said?
Such.
Yeah, what is that you
So
said? There was something, right? What one?
yeah, so there is something called a single
Okay.
Single construct. So we'll study about this, but so this is also not the case, but what you were asking, like ordering based on
Okay.
a particular thread ID. But yeah, it will provide what it will do is it will uh, allow only one thread to enter the structured block of code. Other threads will bypass, only one thread will enter.
Okay.
But yeah, I think ordering is, as far as I know, such thing is not currently allowed. But yeah, I need to check that. Okay, any other questions apart from this? So I hope at least you got what is the data race and what is the critical section. We'll understand this data thing in more detail in next section, but because since we are running out of time, let us quickly cover one sample code that I want to share here. So let me save this. So we have this code, right? This is a very small, simple code. I want each and every one of you to look at this code and give me, tell me what will be the output of this code. So we are just importing the libraries here, nothing great. Just this is the main part of the code. I want each and every one of you to try and tell me what will be the output of ABC here. So, at least we can get some clarity that you people are completely understanding what we are trying to do here. So please try and solve what exactly this function does and what will be the output. And you can unmute yourself and tell what will be the values for ABC.
Now or some other later?
No, now only, because I think we have some time, right? 5-10 minutes. 5 minutes we have.
Oh, sorry, I don't now have you Linux or something. Maybe I can give it later for you. Will be in the email or something.
Yeah, maybe that's fine. But I request others to try if you have some time. Or if we want, if you people want to discuss this during next session, then that is also fine with me. But let me know what you want, so we can keep it for now, or we can.
A should not get printed, right? Because it's in the local scope. But how are we accessing A during the printf?
Yeah, so this question should come up. Anyone have the same question? Anyone else who is facing the same, question or having the same doubt?
Sir, but it is still in main function. It can be still part of the output, right? Like that structure block is only for this block is independent, like is still part of main function. Like it is just for our pragma that we are making it as a separate block, but still A can be printed, right?
Yeah, so anyone else who would like to go that A, go with the thought that A can be printed here. Please feel free to add. It's not like right and wrong. We are just having some discussion here. So even if you're wrong, it's okay. Important thing is to try so that we can get some understanding around what we are doing. So please try and let me know, like, what do you think, whether it can be printed or not, first of all. So that is question number 1. Can he be printed?
So I don't think A should be printed, because once we exit any structured block, even in a serial or a parallel code, the local variables will get popped off of the stack that was allocated for that particular execution. So out of that scope, I don't think A should be accessible.
I think that is a good explanation. Yeah, any other thoughts? Or yeah, if there are no, then I can go ahead actually. So okay, any other thoughts? Okay, so yeah, that explanation was correct. So let us try to understand this. So we'll end with this, like here. So whenever we declare hash pragma-omp, use this hash pragma-omp parallel num threads, what essentially happens is that the structured block of code after that is executed in parallel. So if you remember that our diagram, right, where the master thread was forking the threads, child threads, and it was running this structured block of code in parallel using all the team of threads. And at the end, if you remember that all other threads other than master threads were parked. So there was no, so there was no other thread apart from master thread is running this serial piece of code. And the point here to note is that this integer variable a is defined inside the thread. So let me go back to this. So whenever a variable is declared inside a structured block of code, I mean inside a parallel region, it's a thread private variable, and it will be stored inside the stack, I mean stack of the thread, a particular thread here. So the point here is that that variable will only be accessible, I mean, by each thread, and once that parallel region is completed, the thread itself will be parked, and so the variable, so this entire thing, this entire thread will be parked, so it will be terminated. So the variables that it hold, the private variables that it hold, will also be parked along with that, right? So uh, the point here is that the variable a won't be in existence here. So a will no longer be available here. And if you try running this program also, let me quickly jump to the shell. See, it is giving error, right? That a was not declared in this code. So since threads are terminated, and so is the private variable which are present inside it, so the compiler will not recognize this variable a, right? So that is what is the error. I hope you, I mean, every one of you got this point. And if there is any question around this or any other question that you have in mind, then please ask that also. So I'll stop here. We'll discuss the output and everything in the next session. But yeah, for now, I hope you got why we can't have a inside, I mean, a outside here, printed here. Any questions? So we are already out of time, but yeah, if there are any questions, I'll wait for a few more minutes so that we can get it clarified.
Sir, last time I had asked one question regarding the go to statement. So you had asked me to
Yeah.
try that, putting go to statement in the
Yeah.
function. And so what I found is, if I keep a go to statement that is outside the scope of this pragma part, like of our the pragma structure, then it will not compile only. If it is within the go to statement, the jump statement is within the within our scope, then it will be able to combine and go also. But again, if there is an exit statement within any function, then it is still compiling and exiting also.
Yeah.
So if
So
there are
exit
multiple
will
threads, but
work.
any of the thread exit, yeah, exit will work, but go to out of this will not work.
Yeah, that is correct.
But
So
sir,
exit it.
adding exit, uh, but exit
Yeah,
will
go ahead. Sorry.
also, will it not also hamper the parallel like thread? How, what will happen to other threads? Will they just get killed
Yeah, so that
because
is
of
a good
this?
question. I haven't tried what will happen when, let's say, you exit. But yeah, the most possible scenario that I can think is that all the threads will be killed, and the entire process will get terminated, right? So when you do exit, the entire process will get killed, right? So will be the threads that are inside the process. So that is the most possible thing that should happen when you do exit.
Like means that is allowed, but why that is allowed? That was confusion. Like because we are not allowing it to come out of thread outside this of any one thread, but overall process we are allowing to terminate. So
Yeah, because I
maybe that.
think the reason is that when you do exit, the entire process is getting killed, right? You are not just restricting any thread or anything. You are killing the entire process. So that is the reason you can kill the process, right? I mean, in Linux also, if you want, if there is some process running, there might be threads inside that process also, right? Which are running along with that process. And if you want to kill that process, you can kill that process using some command, and that is completely okay. I mean, you can kill the process. The same is the scenario in
Yes.
this case. Yeah, so one thing that I wanted to, that came to my mind when you were talking about this exit, right? Sorry, go to, right? So you can actually place the return statement here, right? And it will compile fine. So return is somewhat like, I mean, it's not go to, but it's somewhat jumping, right? So let's say your execution came here, TID, and when it returns to this part, right? I mean, after this somewhere here,
Yeah,
but
it
it's
is
still
still
inside the
within the
structured
scope
block.
basically.
Yeah,
Yeah.
it is still within the structured block. I mean, it's the end of the structured block, but yeah, it is still within. So this one will compile fine. But let's say you add some go to, which is going outside somewhere here, then it won't work. So that is
Yes.
the point. And yeah, return, sorry, exit is an exception here because we are killing the entire process in that case. Okay, any other question? We'll see this one in the next session. What will be the output and so on. But yeah, any question apart from this, whatever we discussed today? I'll wait for 1 more minute and then we'll call it a day. And yeah. Or anything you would like to improve, like if you people would like me to cover anything special, then also to let me know, like if you feel anything is missing or I should add something or teach in some different way, then also to let me know so that I can incorporate that also. So is the speed okay? Are you able to understand? Is the pace okay? Is the amount of content that we are covering is okay? Or anyone would like to add anything? Anything that you feel like should be improved or anything like that, then do let me know. Either here or in the Google group. I'll take the suggestions and we'll try to update this stuff. Okay, if there are no suggestions, so if there are any questions then or suggestions, then post it on group. And if there are no suggestions that you have right now, then let us call it a meeting and see you all tomorrow at 5 p.m. Bye.